It takes us 5 episodes to get here. We got an LLM which can think, which can actually reason, which can store the data, which can act. But there was still one missing piece. Today, we'll talk about agents. We'll build the first agent real and so via code at the end of this video. So welcome Agentic System Design episode 6. This is the last part of our first concept sections where we will talk about the agents. After that, our engineering section will start where we will actually deep dive into the specific sections and it will be more technical depth hands-on thing, right? So in our last episode, we asked a question, what is an agent really? We build a model which can think, know and act, but this still the question was remained, right? So let's recap it quickly before moving to the next. So 5 episodes, let's quickly recap what we did. In episode 2, we talked about the primitive, which means like we talk about LLM, which can do a pattern matching, what is pro, what is cons, and then we talk about how we can make LLM think harder, where we talk about the chain of thought methods and reasoning model. And then next thing was like how we'll give the custom knowledge LLM was not trained on, right? We talk about the RAG, how we using the RAG we will give the custom knowledge to LLM. And then in the last episode, we talk about the acting part, which is like giving the tools, like how we will make LLM enable to do something into real world, right? Now, something is missing. What's missing? Something to decide what next after every action, right? So we will talk about that into this episode. So think, act, observe, and repeat. If you see, if you think like before the AI era, when we was doing the debugging, so how we used to do, for example, we found a bug, we go and search that bug on Google or Stack Overflow, we found some response, we applied it, build it again, and if that bug or issue resolved, then it's fine. If not, then again keep the new error and go ahead search. So we have to kind of keep repeating the loop until the issue was resolved. And this was like we always used to do it. For example, first think, okay, we find something, we search on Google and Stack Overflow, we find like, okay, what to do next? Then basically act, where like actually we are copying that method or we are implementing it and then running it. That's kind of act. Next is like observe. So when you are running it, what the response is coming, whether it's a success or a failure, is kind of observe the response, and then based on that we decide what to do next. So if it is solved, we just go ahead with it. If not, then again same thing repeat, like think, act, and observe. So see, this is like a very simple 3-step process, but this was the fundamental base of our overall thinking, and we used to do it into our daily life very like often, but sometimes we don't even realize it, right? So if you just keep that thing into a loop, that's form the whole model of reasoning or thinking in like humans or in any system, right? So if you see, this is also into the LLM, we use the same thing. So we think, act, observe, and we keep repeating it until we found the answer. If we found the answer, we just return or basically keep repeating. And you can observe when we are using like a coding agent like Cloud Code or Codex or anything, and they usually do the same thing. They apply something and they recheck it and then reapply it and keep doing it until the objective is met. And sometimes what happening is like they also give up. Previously there was a problem where they keep doing it and they get stuck. Right now, if like it didn't solve in like 4, 5, 6 a certain amount of loop, they will just say, okay, this is our finding, and they will basically try to close that loop to not keep running that infinity, right? So this is like a very simple idea to actually thinking or putting a intelligence into the system, right? And it has a name called ReAct. Okay, so ReAct is a short form of like reasoning and acting. In 2022, basically there was a very famous research paper published by collaboration of Princeton University and the Google, which actually write this into a research paper that how the reasoning will work, which is very simple, but it's basically formalize it. And right now, whatever the modern system we are seeing, modern intelligence system, like whether it's a Claude, Gemini, or like OpenAI system, anything, everyone follow the same pattern where they basically think and then act, then observe and then repeat, and they keep doing it until the output is done, right? So this was like a paper, original paper. I will also put the link into YouTube descriptions, and it will be on the website resource section where you can go and read this. This is very good. But on a summary, this was just like a loop. Basically, we have to think, act, and observe, right? Next thing is, do you really need an agent before you build one? So this is a very important question. Now you know like what agent is. Agent is basically a loop which will think, observe, and act and keep repeating it. But before going further, the good question is, do you really need an agent or not, right? So most these days, like what is happening is this AI is so much in hype, like every company, everyone want to build agent, like everyone's saying agent, 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 and sometimes it's like overwhelming, right? And there is a cons to it also, right? For example, if you see, when you are running into the loop, it is costly, because every time you are running, it is you are expending money, right? And if you're running it for a multiple times unnecessary, you will spend more money, and it will comes with more different problem we'll talk about, right? So first thing is, do you actually need an agent or not? Let's talk about it, right? So Anthropic itself says into their very famous paper, like building effective agents, where they say, don't build agent if you can make things work with workflow. So it's like Anthropic official recommendation, don't build agent if you make things work with the workflow. So let's discuss like what is this workflow and what is this agent, because this is very important when you are designing a system, right? So steps are predictable. So before deciding where you need an agent or not, just think in your mind, can you define the problem as a flow chart, like every step it defined? If your answer is yes, then you don't need agent. Simply build a workflow and you are done. But if your answer is no, I can't define my problems or the solution or the steps as a workflow, which means it is right now you don't know. I mean, you will decide on the fly, like you will calculate something, and whatever the response will come, you will again recalculate it, which means you need some kind of reasoning, you need some kind of intelligence. So you need agent, right? So this is a very simple thing. For example, if your steps are predictable, A, B, C, and to give like some example, for example, you build in a system which will read your ticket and basically triage to the multiple team. Here, you don't need an agent. You just need an LLM, which will, you need a workflow. What workflow will do? It will read your tickets, pass it to the LLM. LLM will kind of process it, and then it will simply say that, okay, you need to go to this specific, assigned to this specific team, and your tool will basically assign to that specific team. That's like a simple solution. Or the next example is, for example, you are building a system which will basically summarize your email, right? Again, you don't need an agent, because it's a simple call. You need to fetch the email and basically call some API of LLM API, which will basically summarize it and give the response, right? You're seeing these are like simple things. So if your steps are defined, you don't need an agent. Again, I'm not saying you don't need an LLM. You need LLM. That will be again agentic system, but you don't need agent. It can work with the workflow, right? Next thing is, when you need agent, when it's depend upon when you cannot define into a workflow, then you need agent. For example, you're doing some complex task. For example, we're building a coding agent which will actually do debugging. So now you cannot write a workflow. For that, you need an agent. And again, what agent will do? It will simply same three things: think, act, observe, and repeat kind of thing, right? So this distinction must be clear as an engineer, that if your problem statement can be defined as a flowchart, you don't need an agent. You will simply build workflow. And if your problems cannot define as a flowchart, which means you need an agent. So this thing crux, keep in mind, and very important for throughout agentic system design, right? So what the real agent look like? So simply, it's a 50 line of code. That's all, right? How does 50 line of code look like? Let's see. So if you see, this is a loop with a budget. So it is doing nothing. It is basically, first it is calling the LLM, which is like a think, and then once the LLM is either it will give the response, then it will exit, and if it didn't give the response, then it will say like make some tool call. So that will be like act, and then whatever the tool response is coming, it will simply feeding to the LLM, which will basically observe it, and again give you the response. Either it will exit it, give you the response, or it will say to make tool call again. So simply repeating this loop is called agent, right? I will also show you the real code. I built a demo like how this will work in a real life, and then it will be like very clear to you, right? So let's go to the real demo, and then we will understand like how it will look like. Yeah, so let's see the demo. I have created a repository for you, Agentic System Design. Basically, this is a center repository which will contain all the code throughout this course, whatever we are studying, all the demo codes, and also this is the first start. But in our engineering section, we will talk about our design docs. I will give you the design docs templates and CDK code, multiple codes. So this repository will contain everything, right? And the link of this is already into the YouTube description, or you can see on the resource section of course website, or you can visit my GitHub. You can see that and you can use it, right? So before going much further, I will just go. I created an example folder and first agent. This is like our index file, and before so what is happening is this is basically this is a task. let me define the task. Task is very simple. I create a file, and this file is a dummy file which contain a revenue, operating cost, and headcount of a company, just a dummy company. And the task is like read this file and then tell me what is the Q3 profit and the profit per employee, right? Simply, this is a very, very simple task. You can say I can do anywhere, but why we need like agent? But no, because if you see, the task is basically a natural language, like read this file and tell me what is the profit, and for this you need something to process. And the first thing we are doing is here we are calling checking that our API key is available or not. And I'm using like Anthropic API key. Why? Because throughout the course I will use like Anthropic Claude with Bedrock. And why? Because this AWS and Anthropic are really scalable, and if you are building a real production system, we will choose something which can follow up throughout the course. Again, there is nothing specific about it. It's just it's not a sponsored by Anthropic. It's just like my personal experience. But if you want to do not want to spend money, you can use the Google Gemini free tier. You can just give this repository to Gemini and say to convert it for Gemini, and you can go to Google AI dashboard, create your own API key and use it. How it will look like, it's simply this is my example. Like here will be the key. You can generate a key from their website and use it here, which is into environment.local. I'm not showing it obviously. And what will happening is this like my code is first checking if key is present or not. If a key is not present, it will simply throw an error, and then simply console log, and then it's calling the run agent, basically the function with the task. What the task is basically this, and the tools, like what tools we have, and we'll talk about the tools next part of it. So let's see like what's the run agent look like first. So this is the exact function I show you. The run agent is basically nothing. It has some like system prompts, and then it is basically a for loop. Start from 0 and step is equal to less than max step. Why the max step? Because we don't want to like keep running our agent into a loop. So this is like a safety things that, okay, even if you are running it, the max step will be like 8, 10, whatever you have decided, but your agent should not run more than this. Otherwise you are going to get like a lot of bills. So this is just for a safety check. And then what is happening, it's simply we are calling LLM with the message, like whatever the prompts or the message we have, and we are passing all the tools we have locally, right? I talk about the tools, and tools is a functions, and I say these tools don't run inside the LLM. Tools run on your own system. LLM just call you that, okay, I need this tool to run, and you as a basically agents, you actually run on your local system. So we are but simply calling LLM with our tools, what tools we have, and then we are waiting for the reply. And if reply is done, which means like if LLM finish replying, simply returning it. And if reply is not done, which means like it's in the middle of the process, we are basically so if reply is not done, which means LLM want to run some tools. So what we are doing is we are actually running the tools, and LLM reply that tools call. Basically like we pass the tools array to LLM, right? What tools we have. Now whatever the LLM said, okay, to call these tools, we are calling that tools, and then again we are creating a message, whatever the response coming from that result, right? See the result, and we are basically passing the result, and again calling LLM. So here the loop will end, and we will go again and we'll call the LLM. So it's kind of keep repeating it, right? And at the end, whenever we get a response, we will exit it. Otherwise, we will be simply kind of max step. When it will cross, it will finish, right? So let's go and see the demo first. Like I'm opening here where we are. Okay, I need to go to example directory, and I will run the npm start. And if you see what is happening is task. This is the task. So first thing, it basically call. Okay, so think step output. So when we call the LLM say call read file this. LLM say okay, read this file for me. And then next, what happening is like act stage. So our agent actually read the file, and after that, this is the output where say like revenue, this cost. Basically, just read the file and give it to the LLM, right? And then next, the think section. LLM basically think about it, read the file, and then again give back that call calculate function, like but just calculate the total minus the operating cost, so that we'll know what the profit is. And again our local system act on it and give the profit. LLM again think about it and say okay, call calculate expressions, and basically what was the profit divided by the employee, and our local system run it and give it to the LLM. And what LLM do is LLM basically say okay, we are done, and it's return the response. And what the response was like Q3 profit is equal to 125k, and then profit per employee is equal to 8,928, right? So this is the simple thing. If you see how these things are happening, right? Before going, just few more clarification of the tools, how it's work. If you see, we call about, and this is a very simple thing, I think you might be already aware, but just I will quickly recap. When we say npm start, what does it mean? Like, so if you see in our package.json, we have a script called start. So basically hit the whatever you define here. So it is saying, it is basically running this index.ts1 only, which we already defined here. And if you see what it is doing is right now just checking it and calling run agent. One more thing which is very important, I will define what the tools is. If we say we have like two tools defined. One tool is read file for reading actually the file, and you see we already discussed this into theory, but right now you see into practical. We have like what is the name of this and description, read a text file, like what it do and what is the schema look like, and then the one is a run function, actually how this tool operate. So basically if you see it's a function, if you just give a file name, it is basically actually reading. How it is reading, I'm using like a node API to actually read the files, and then at the end basically returning the file. You see everything is defined by us only. And the next is calculate function. This is a simple function which will basically whatever the expression you give, it will do some calculation. And what is this tools and all look like? So this is like a simple tool definitions, and this is a tools array which say like read file and calculate. There are two tools available. So whenever we are calling LLM, we are also attaching whatever the tools available, right? So this is a simple demo, but this will kind of give an idea about whatever we have studied in like before lectures. It is kind of everything coming into a code, we can visualize it, and then we'll see later more complex version of it, right? So now we see a demo like our agent, and looks very simple, but the thing is now it will break in 30 ways, right? When you actually build a system which will deploy into the production, it will basically break in multiple ways, right? So next engineering section will talk about it, that it's not like 50 line of code. There are like bunch of things happening inside. So just I will give you a quick preview what will be coming into the engineering section. So it will be like very fast preview. So it's like we will talk about the design discipline. So here we'll talk about like main thing back of the envelope calculation, how we will actually calculate matrix, like how much token we will consume, what is the latency will look like. And this is very important when you are designing an actual system, as well as in the interview, because when you are doing this designing of agentic system, you need to calculate few things, right? So that is the most important, how to write the actual design doc. If you're working in a team, you need to write a design doc, present to the SD, like teammates. So how to do that? So these all things will be here. And then we'll talk about the reliability and the memory, how we'll like build this ReAct thing, vector, memory, failure model, all those things. And then we'll talk about development to production, right? So you build it, how do you test your agent locally, how, like what is the SDK look like, and all those things we'll talk about into the chapter 4. And then evaluation. So your agent is throwing some output, but how will we evaluate that whether it's right or wrong, right? So obviously like there will be another LLM which is going to judge the output, but what is the matrix about it? So this is called like evaluation framework. We will talk about that further. And then obviously observability and the cost. So it's not like just we will build and forget, because we are building a real production system. So as like a normal system, we will put a matrix around it, and we will put log around it. So this like it is the best practice and how we will actually monitor. So this will come here. Next is like security and human in the loop, right? So this is most important, like if you building an agent, how to make it secure, what is the different ways. So what is the kill switch, like if your LM is going out of like hands, how to kill it. So all these things we'll talk about your agents, right? Next is like build it for real. So once you build everything, how you will actually deploy, because your agent is not going to run on a laptop, it will run on into cloud or somewhere, right? How you will actually deploy, what is the best practice about it. So we will talk about everything. Again, these are like high level chapter, but inside that there will be multiple episodes because these all things are important. So you can go check on the website. I have mentioned like how many episodes each chapter will be, which will give you the idea. Yeah, so next section, engineering section, is going to be very exciting. See you there, right? Bye bye.